Lesson 409, Secants and Tangents, Part 2. The objectives in this lesson is to find the measures of angles formed by intersecting tangents and secants, find the measures of intercepted arcs formed by intersecting tangents and secants. The measure of the inscribed angle is half the measure of the arc. So there's the inscribed angle, x divided by 2, and then the arc is x, and you can see I've highlighted the arc in green. The measure of the interior angle is half the sum of the intercepted arcs. So you've got x plus y divided by 2, and your arcs are x and y that you see I have marked right there. So to find the measure of that angle, you're going to add x and y and divide by 2. Okay, the two lines, see we're talking about secants and tangents, and the two lines can intersect outside the circle, just like these two tangents. These lines can be either two tangents, a tangent line and a secant line, or two secant lines. This lesson examines each case where the intersection occurs in the exterior of a circle and the corresponding relationship between the measure of the angle formed and the measures of the intercepted arcs. So we're just going to jump right into some examples because that's usually the best way to explain these. Says if the measure of arc ADB equals 250 degrees, what is the measure of angle APB? So there you have two tangents, and let me get my pointer here. So we've got arc ADB. So here's arc as A, it goes around to D and B. So that's a major arc, 250 degrees. What is the measure of angle APB? Okay, so remember I always like to write out a problem. Oh, let me turn my pen on before I start flipping through slides. Okay, if the measure of arc ADB is 250 degrees, what's the measure of angle APB? Okay, so I like to write out our problem. So let me see here. I've got the measure of arc ADB is going to equal, get this, 360 degrees, because that's the measure of the whole circle, minus, oh, I put too many letters in right here. Kind of got excited. So there's the measure of arc AB. I'll rewrite it correctly in just a moment. Oh, let me put my measure. ADB. There we go. So I've got, this is what I'm looking for, because I've got to find this out in order to solve for my problem. So arc AB is going to equal 360 degrees minus ADB, which is 250. They gave us that information right here. Okay, so the measure of arc AB, which is a minor arc, is going to be 110 degrees. So that's right here. My 250 is out here. So to find the measure of angle APB, so measure angle APB, that's going to equal half the measure of arc ADB minus the measure of arc AB. So measure APB, there we go, half. We know that it was 250, the major arc, because they gave us that information, and then we calculated the smaller arc was 110. And some of you may be going, oh, why is she going through each of these steps? And it might be a little boring to you, but you have to remember there are others out there who need to see each step. I'm one of those people, believe it or not. So half of 140 is going to equal my my angle, which is 70 degrees. There we go. Okay, let's go ahead and see what this, I think we're still working with two tangents. We are. There we go. It says if the measure of angle APB is 34 degrees, what is the measure of arc AB? That's that little arc right there in the middle. Well, let me see. Let's figure this out. It says I've got the measure of arc AB is going to equal 360 minus the measure of arc ADB. All right, so we've got the problem set up. Minus arc ADB, all right. So the measure of arc AB would equal 360 minus x, because we don't know what the measure of arc ADB is. So I'm going to come over here and I'm going to put an x right there, x degrees. Okay, so now I need to find the measure of angle APB, which equals half. Well, I'm not finding that measure, I already know it. The measure of arc ADB minus arc AB. Now, don't forget this step up here that I just did. Okay, that's going to be important. Right now, it's going to come into play. The measure of that angle is 34 degrees. I've got my half. Remember, we said the measure of arc ADB, we're letting it be x, minus the measure of arc AB, which we figured out right here. We said that is 360 minus x, just like that. Oh, let me put another set of parentheses there. Okay, so now I want to get rid of that half, so I'm multiplying both sides by 2. And remember, these reduce to 1, so it just kind of disappears. So I have 68 equals x minus 360 minus x, with my little parentheses. Now then, you've got to remember from algebra that anytime you have a negative in front of your parentheses, that means you're multiplying everything in the parentheses by -1. So I've got x minus 360 plus x. So 68 equals 2x minus 360. Now I'm going to add that 360 to both sides. And I have 428 equals 2x. Divide both sides by 2. And I have x equals 214. So it looked like we didn't have enough information, when in fact, remember, we can always just plug in an x and figure the rest out. So if I want to know what the measure of that little arc AB is, remember what I did up here? Right here, I said the measure of arc AB is going to equal 360 minus x. I just found out that x equals 214, so the measure of arc AB is going to equal 146. Okay, this is one of those problems that had multiple steps. We had to come up here and figure out an expression for the measure of arc AB, because we thought, oh my goodness, we just have 34 degrees, that's not enough information. And then this was our second step when we used the measure of the angle to solve for x, And then our third step was actually finding out what the measure of arc AB was. So be on the watch out for multiple steps like that. Okay, if the measure of ADE, that's arc ADE, equals 170, and the measure of arc AF equals 80, what is the measure of APF? Angle APF. I keep forgetting the important information. So there's 170 degrees. This arc over here is 80 degrees, and we want to find out what the measure of that angle is. So this one isn't going to be one of those multi-step problems. Thank goodness. To find the measure of APF, angle APF, we're going to take half the measure of arc ADE, oh, forgot my little m, minus the measure of arc AF. Okay, so I've got measure angle APF equals half. The measure of ADE is 170. They gave us all this information. Arc AF is 80. So that's going to be 1/2. 170 minus 80 is going to give me 90. Half of 90 gives me 45. So the measure of angle APF is going to be 45 degrees. That angle right there, 45 degrees. So notice when I'm trying to figure out the measure of these angles, whether it's two tangents, a tangent and a secant, or two secants, I'm always taking the intersecting arcs, adding them together, and dividing by 2. All right, that's how it works every time. Okay, now this one, they said the measure of this little arc, and I'm going to write it right on the arc like that, 62 degrees. The measure of arc EF, whoa, that's another one they're throwing at me, is 138 degrees. What is the measure of the angle? Well, I've got to know what the measure of arc ADE is. Okay, well remember, the whole circle is 360. So if I subtract 62 and 138, I will find out what the measure of that arc is. So, let me see, so that's 360 minus 200. So that's going to give me 160. So the measure of ADE equals 160 degrees. All right, so now I've got enough information to figure out what that arc is. I mean that angle. So I have the measure of angle APF equals 1/2. Remember, I just add up those two arcs. That's going to be arc AF. Oh, yeah, it is a plus. I almost confused myself, thought it should have been a minus. ADE. Okay, so that's going to be half 62 plus 160. 62 plus 160 is going to give me 98. Half of 98 is going to give me 49. And I just didn't want to write that over again and again and again, so there you go. That's the measure of angle APF, 49 degrees. Alright, boy, this video is taking a little longer than I thought it was going to. It says the two secant lines shown here meet outside a circle. This is the third and final case of lines that intersect outside the circle. As before, the measure of an angle formed by two secant lines intersecting in the exterior of a circle is equal to 1/2 the difference of the measures of the intercepted arcs. So we just got a couple, no, we just have one example here. It says the measure of arc GE, which is this outside one. Oh, what is? Let me see if I got this right. Okay, I don't know that. If HPE is 30 degrees, and HF is 20 degrees. Okay, it's all making sense to me now. And it wasn't that long ago that I actually typed out this problem. So I must have some short-term memory issues. So that's the measure of arc GE plus the measure of arc HF. Okay, so this is what I'm looking for right over there. So I know the measure of the angle is 30 degrees, and I've got my half, measure of arc GE, and I know that HF is 20 degrees. There we go. Remember, I got to get that 2 away, so I'm multiplying both sides by 2. These little guys right here reduce to 1. So I've got 60 equals the measure of arc GE plus 20. You know what? I apologize. That should be minus 20. Because I was wondering where I got was getting my answer all of a sudden. Let me come over here. Let me fix this so, because I don't want anybody confusing whether that's a minus or a plus. Let me make sure I put a minus in there. I got so used to writing pluses a while ago, I just went to town with it. So I'm adding 20 to both sides. So that's going to give me 80 equals the measure of arc GE, and of course those 20s cancel each other out. So that arc right there is going to be 80 degrees. There we go. So, what we learned today. There are 3 possible configurations when 2 intersecting lines touch or intersect a circle. Where the pair of lines intersects could be on the circle, in the interior of a circle, or in the exterior of a circle. The theorem that applies to the 2 lines that intersect is determined by where they intersect. And when tangent lines, a tangent line and a secant, or 2 secants intersect in the exterior of a circle, the following is true. The measure of the angle formed is equal to 1/2 the difference of the measures of the intercepted arcs. So when you get finished watching this video, you need to read through the lesson 409 Secants and Tangents Part 2 and complete the student guide. Read the lesson and the reference guide and add extra notes if needed. Then you're going to have to complete 2 whole problems in the problem set, 11 and 13. And after you do all those steps, if you don't understand any of the concepts, please contact me or attend TOGA if you have any questions before you complete the 4.09 quiz. And as always, make note of any general questions you may have when you attend CC this week. And as always, always give me your course and section number with all communication to me, because that helps me help you faster. That's going to be it for lesson 409. Thanks for listening.